When we talk about the set, it reminds me of a Simpsons joke. I don't know if you watch The Simpsons at all, but there's a point where Simpsons becomes a stonecutter. I think is the name of the group. It's making fun of Masons a little bit. I think, um, and he becomes the chief of the stonecutters after not being allowed to, and eventually, and kind of ruins the organization. And everybody leaves the stonecutters and creates a new society called the No Homers Club. And the joke there is they have one Homer, but there's no second Homer allowed inside the club. And that's exactly what a set is. You can have one of everything, but not more than that. So a set by default does all the things that a collection does. It doesn't add any additional features or functionalities, though. I add items in, but there's no assumed order to what goes into a set. That's not part of the features inside of there. I can't remove things explicitly differently from a set. I can't reorder them explicitly differently from a set. Because the most important thing when I add something to a set is I have to look through every other item in the set and make sure one of those things doesn't exist out there already. I can't have more than one Homer, as we said. So the interesting thing about the set is how do we store the information and how do we track what information is stored, because it can be slow. If I have a deck of cards and you hand me another card, I've got to look through all the deck of cards in my hands to see if I have that one already before I can add it in. So the types of sets are around the idea of what gets stored inside. So the two primary ones is the hash set and the tree set. Again, we'll talk about the storage mechanisms as we go, but the most important thing about this is the hash set has no order tracking inside of it. There's no explicit or implicit order to it. They're just randomly assorted. So when I go and iterate through them one at a time, I have no idea what the rules are by which they come to me. It's not entirely random, but it's mostly random. It's essentially random as far as we're concerned. A tree set has an order associated with it. That order is defined by however you compare the objects. So if I'm adding in people's names, they're probably alphabetical. If I'm adding in cars, it might be ordered by their VIN number. Whatever we use to compare the objects is what gives us an order. So they're going to come out in some defined order that you defined based off of how you know our two objects equal. The linked hash set is very similar to the hash set, except for we actually track the order. We actually have a mechanism inside the track the order. So if you care about it, you can use the linked hash set, which makes it a little bit slower, a little bit fatter, but if you need to track it in some way, then you can. And then the enum set, don't use very often, but it's a special set used for enumerators. Enumerators in Java are basically a special data type that allows you to define essentially an ordered list of stuff that only has a discrete set of numbers, values inside of there. So when we talk about the hash set is all about speed. To really understand the hash set, you have to understand the notion of hashing, and we'll talk about that more when we talk about the hash map, because that's where it makes a little bit more sense. It's not important in the set. The hash map is going to be important for how we store things. In the set, it's basically just a quick way of looking stuff up. So there's, again, no special features to this. I'm just inserting stuff, and the best part about a hash map is how I do the searching. I can find my objects very, very quickly and see if there's a matching duplicate to my object. I didn't have to look through every one of them, essentially. The hash set allows me to cut it down, so I only have to look through some limited number of objects and check equality. The tree set, likewise, its implementation is actually not given in the set. The tree set is defined by using the ordering mechanism in a tree map. So the tree map basically creates this tree nodes of objects, and we'll see it more when we talk about maps. But it searches them by splitting it in half. So you think of the alphabet, we'll just say alphabetically. All the A through L's go to the left, all M through Z's go to the right. And then we break it down kind of like that. So A through F goes to the left, and then F through L goes to the right. So that's basically what a tree does. It bisects it, giving us half of the list, and then half the list, and half the list to be able to sort through. So again, the main functionality is how do I quickly determine is there a match inside of it? But I'm not showing the implementation here because it's not actually in the tree set. It's in the tree map. It uses the tree map behind the scenes to solve this. So we'll see the actual implementation when we talk about maps. Now, there is such thing as an interface called sorted set. The sorted set is basically saying I have this set out there, but there's some sorting rules. And there's a Java interface that lets us differentiate between basically the hash set and all the rest of them that are sorted sets. I just pointed out to show you this capability, that I don't necessarily have to live with that, as I must deal with specifically a tree set. In our Java code, we should never use as a variable tree set, hash set, linked list, array list, any of those things. We should always use an interface. List, collection, set, or sorted set. So we want to see these things in action. There is another lecture here, I'll call it optional, on the map. You don't need it to get your work done. I think it's highly interesting. But again, if you're up to your eyeballs in information, it's okay to skip that one for now. Maybe download it, come back to it when you feel a bit more comfortable with this stuff. The set and list stuff should be a simple little addition to this. So go look at it in the code and go see it in action. These are just kind of a precursor set of lectures to get your mind on what these things are. And then remember these pictures when we get into how we use them in action when we're looking at our demonstration.